If they cannot adapt, where will they go? Will they go to waters that have a higher pH and are more supersaturated? If so, what happens to the ecosystem that's left behind? What happens to the fish that are dependent on these organisms for their food? This is a very serious question. And for coral reef systems in particular, for example, the skeleton of a coral reef system is the major home for 25% of all our fisheries that live in coral reef systems during some portion of their livelihoods. So it's a critical component of the ocean ecosystem. On a global basis, about 20% of our food resources in terms of protein comes directly from fish resources. So any changes to the ecosystem will have a direct impact on our food resources from the sea. From the pre-industrial to the present, we know that the surface water pH has changed by 0.1 units, a 30% increase in acidity. Over the last 30 years or so, we have been able to specifically measure the changes in pH and the changes in CO2 of our surface waters. We do this at the Hawaiian Ocean Time Series off of Hawaii, which is commensurate with the Mauna Loa record in the atmosphere, which is also off the Big Island. We do this off of Bermuda. We do this in a number of locations throughout the world oceans. So our ability to monitor these changes have taken place. You can go back further in the geological record and look at ice core records to see what the impacts of CO2 have been and the changes in CO2 levels in the atmosphere. And what we find is that the atmospheric concentrations over the last 800,000 years or so have changed between about 180 parts per million and 280 parts per million. But we are now as high as 385 parts per million at present. And by the end of the century, we could be as high as 800 parts per million. And we can see from the sedimentary record and the ice core records that these changes that are taking place throughout this century, out to the end of the century and into the next century, far exceed anything we have seen over the last 20 million years or so. Clearly, in the very far distant geological past, 35 to 50 million years ago, we've had CO2 levels that were much higher than they are at present. The difference is that the rate of change of CO2 is so dramatic now that it far exceeds any changes that have taken place in the past. We're changing the ecosystem so fast, we're changing the ocean system so fast, that many of the organisms don't have the ability to adapt to these changes that are taking place.